What is up, you guys? So in the previous lecture, we talked about threads and processes. Namely, we introduced you to two concurrent programming models that are multiprocessing and multi-threading. We also wrote a simple hello world function, which is called myfunc, that just prints out, so are we there yet? We opened the thread to run the function on, and then we showed that a thread could be either joined or detached only once. And lastly, we showed you a way of joining a thread. So to avoid a crash, let's say the thread could not be joined again, and that's when we said once detached, always detached, you cannot join again. Then a proper way of testing if you can actually join a certain thread is just by calling the joinable Boolean function. Okay? Now, what about if a thread is neither joined nor detached? What can we do? So in other words, if a thread object, in this case T1, is destroyed before the thread is either joined or detached, program will finish. So you have to decide whether you want to join the thread or detach before T1 goes out of scope. So in other words, let's say I join the thread, so T1.join. And in the main thread, after it creates the T1 thread and before it joins T1, we have to do some work, otherwise we're not exploiting threading to the max, right? Otherwise, why just not call the function myfunc as such, right? Instead of this. But to make full use, you better be doing something before, huh? Otherwise, you're not completely exploiting the threading functionality, okay? Let's say the main thread main starts counting. So for, let's say, int I equals 0, I less than 10, I plus plus, then I'll just see out the following. Message from main, and I'll just print I as such, okay? Oops, I've got an error here. Should call std, same thing here, okay? Now, while the parent thread is doing its work, it throws an exception. Now, let's suppose for a moment that this is not a main function. It's just a regular function inside a deeper calling stack. And while the parent thread is doing its work, it throws an exception. Then again, the thread object T1 will be destroyed before it is joined. So we need to, wrap up the parent thread with a try-catch block before joining the thread. So we'll try first of all, and we'll catch an exception right here. So 3 dots means any exception, really. There's types of exception, but 3 dots means, any type of exception. So what I want to try, I'm going to try this block right here. Okay? And what do I do when I catch an exception? We'll join, and then we rethrow the exception, just like a rebound, hoping someone would catch that rebound. Okay? So this is a guarantee that T1 actually joins without any exception. Now, an alternative is using resource acquisition is initialization approach, or RAII, right? So in other words, we can use a wrapper class that wraps around the thread T1. So something like wrapper WT1. So whenever W goes out of scope, it will automatically join the thread. Now, a thread object can be constructed not only with a regular function like myfunc, but any callable object such as functor or lambda expression functions. Now, what do we mean by functors? Let's say I've got a class called f. This is my functor, and we'll define a void operator right here. This functor will count, so int I equals 0, I greater than, minus 10, and I minus minus, so we're counting downwards. Let's see out, let's print. Starting at t, let's say, print I and L, and don't forget a semicolon right here, so that the editor stops yelling. And in the main function, you go down here, you call f, which is your functor, and instead of this T1 right here wrapping on the function, we're going to then let T1 call that functor. Okay, so let's make the function first of all. There's an error right here. Should have 2 colons. Make again. All is good. Now let's run the function. And there you go. So what just happened? So both the main thread and the T1 thread, oh, it's the T1 thread. So let me right here T1, make again, run again, and there you go. Run again. We keep seeing different outputs, right? So what is going on? First things first, both the main thread and the T1 thread print onto the standard out, and it creates a very, very big mess, as you can see here. There's no end line, so starting at T1 is, it's stuck with message from main. How is this possible? Why is this not skipping a line, right? Because if we go back here, we're calling T1 and then we're printing the message from here. We're trying this and then we're joining the thread. So why is this giving a mess? What's going on here? Some people may say, I want to save a line of code, and instead of creating the functor, I'll just create the functor on the fly as such. Why is that? Well, let's make the thing first. There's an error saying it's not compiling because of this, error. You can't just create it on the fly, right? With the function name T1. And this function takes a single parameter, which is a pointer to another function, and this function takes no parameter and returns a functor. And the function T1 returns a thread. Now this is known as the most vexing parse or most vexing syntax in C++. So as you can see here, this is one instance of most vexing. So in our particular case, the functor is forming a most vexing syntax. Why is that? Because the C++ standard says whenever a statement can be interpreted as a function declaration, then it will be treated as a function declaration. And the solution here is to add another pair of syntax to explicitly show that this is a functor and pass it as a parameter to the constructor of thread object T1. So far, our threads have been functions or functors that take in no parameters, right? Now let's say my functor takes in a parameter, which is, let's say, a string, which is a message. And instead of this printing, I'm just going to print, all those keeps yelling at me. So std, 2 colons, cout, just print my message, say thread T1 says message and end of line as such. Now why is it yelling at me? Oh, I think I didn't include it. Maybe we should include a string right here. So it's yelling at me right here. Pull in std as such. There you go. Let me clean everything over here. For that, let me create another string. That is, I've got work tomorrow. Not that I don't have work today, but and a semicolon. Let me clean this out. This is a string s right here. Now, how do we do this? How do we modify the thread right here if we're passing it this functor? So since the functor right now is taking an argument that is a string called message, so the way to pass it to the thread is to take s as an additional parameter of the thread's constructor. So as such. And let's say also the main thread is printing out the message s. Let's see what's going to go on right here. Let's make it and run. Let me save it, make it. There's an error. Okay, so you might run into a problem while compiling. So let me show you what I mean. Once you do a make right here for your C++ program, as such, you're going to get this type of, you might get this type of error. Now, if you didn't, that's good. But in case you did, the type of error you're getting is a no matching constructor for initialization of standard library thread, okay? the compiler is not understanding this syntax, and the reason why, if you're using, let's say, VS Code, you can go ahead and tap on Command Shift P. Now, I think this is mostly on a Mac operating system. So once you go to C++ edit configurations, the JSON file, you're going to find here that the C++ you're using is version 17. All those functors, and later on we'll see mutexes and these kind of stuff, they mostly work on C++ library 11. So the way you can do this on Mac is you can run your C++ program using the clang. Pass it std C++11 and the name of your C++ program. Now, we're in this directory and we have a multithread.cpp and a multithread. Once you run this, you're going to see an output of a.out. Oh, so this should be a clang++. Here's your a.out. Now this is what you will run, right? So ./a.out, and there's the output. Okay, this is what the C++ program is giving. Now, in case you don't want a file called a.out, well, all you have to do is pass a -o flag and pass it the name of the output file that you wish. Let's say it's multithread.out. You want the same output name as the C++ file name. So there you go. This is the output file. And you run it as multithread.out, as you can see. Okay? Now, this is in case you're running into errors. This is compiler incompatibility. Now, going back to the output here, we see a big mess. So this is the output, and it's a big mess, but you can still figure out that both T1 and main threads are printing the same message, right? One from here and the other from here, right? Now, since the argument over here in the functor is a string, let's try passing it by reference instead of value. So we save a lot of copies, right? The way to do so is simply by shift and as such, right? So this is the address. Now, believe it or not, even now, the string s over here will be passed to the thread by value instead of by reference, because a parameter to a thread is always passed by value, not by address, not by reference. To prove that, let's say in the thread I change the message to, I don't know, I changed the message. Well, if it was passed by address, then the message, the content of the message should change to I changed the message. Go ahead and write a function, pass it an argument by address, and this will move s from the main thread to the child thread. This is both safe and efficient. In C++ library, there's many things that can only be moved and cannot be copied. As a matter of fact, the thread object itself can only be moved. So if I create another thread, let's say T2, that is the same as T1, this will not compile. As you can see right here, T1 starts, cannot be referenced, it is a deleted function, cannot be copied then. So if I really want to transfer the ownership of a thread from T1 till T2, then I'll have to use the move function. This is where move comes in hand, okay? And now since, T1 is empty, we cannot join it, so we'd have to join the copy of it, or the thread that claimed ownership, T2. Now, keep in mind one very important thing. Each thread has an ID, an identification number, associated or attached with it. To print out that number, all I have to do is cout, or just to display it, standard, this thread, and get ID, okay? Now this will print out the parent thread ID, okay? Now if you're interested in the child thread ID, all you have to do is call that thread and get ID as such. Okay? Or you can do this thing right here inside the child thread. Okay, so this thread, 2 colons, get ID. Okay, so running this is the parent thread ID. Okay, now let's delete everything over here and say I have a very complicated problem in hand. How many threads should I create to solve that problem? Ideally, I should create as many number of threads as the number of calls I have. I don't want to run more threads than my hardware could support. Otherwise, I will run into a sort of overflow, or I will burn out my hardware. Well, that has a name which is called oversubscription. Now, this is a very bad thing because when there's more threads running than available CPU calls, it creates a lot of contact switching. And too many contact switching, therefore, will degrade performance. Now, the C++ library provides a function called hardware concurrency. This will give me an indication of how many threads can be truly running concurrently through my program. For example, it might give me the number of CPU calls. So this is a useful guide for splitting tasks among threads. So that's it for this lecture. I hope you enjoyed it. We talked about a lot of thread management topics, starting from functors to how to pass a thread to a functor. And let's say a thread has to take an argument. So if you want to commute or change this argument, how to do so efficiently using standard ref instead of passing it by reference, right? Also, we talked about standard move, which is moving the ownership of one thread onto the other. Informally speaking, you're copying a thread onto another thread. Last but not least, we also talked about thread identification number, or ID. So how do you get the ID of a parent or a child thread? Last but not least, we talked about hardware concurrency that returns a value that hints or tells you or indicates the number of hardware thread contexts. That's it for this one. If you found this lecture beneficial, please consider subscribing to the channel, liking the video, and if you have any questions whatsoever, you're invited to leave a comment down in the comment section below, and I'll make sure I'll get to it as soon as possible. Thank you so much, and I'll see you in future lectures.